Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is SVN3E, grade 11, workplace science, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you're welcome to call the Wahsa studio at 1-800-465-7144 or 737-4017. You can call the radio station, you can listen on the radio at 91.9 FM or watch on the television at Bell Express U channel 972. You're always welcome to join me live through the Zoom link, which is available from me, the teacher, and also your DEC. Our classes are scheduled on Monday through Thursday from 3 to 4 in the afternoon. And we are wrapping up our first week of our 9-week course. On Monday is a holiday here in Ontario, so we will be closed on Monday. We will not be airing, so our classes will resume on Tuesday of next week. Reminder of what work to submit for marking. The key questions are the ones to submit, the ones with the key icons. They're the only ones actually in your IL booklet, but it tells you which ones in your work booklet you're expected to do. So please do all of the questions that are listed in the back of each of your IL lesson. So you need to, some of them are check your understanding. Sometimes there's activities, sometimes not, sometimes review questions. So you need to check that in the back of your IL booklet, even though they're, most of your work it's from your text or from the workbook, the consumable, but the list of questions that are assigned are in the IL package that you receive from Wahsa. Please show all of your work, your steps, and your thinking. This way I can give you credit for all of your understanding. And if you're making any misunderstandings, I can figure out where they're coming from, most likely if you give me more information than if you give me less information. Make sure you are actually answering the question so that you are on track and not just talking about something in general, but make sure that you're really knowing what the question is asking and answering that question specifically. You're welcome to do it by hand or electronically. So you can write in the workbook, I'm fine with that, and then take a picture or scan it or whatever. Or you can write it out separately if that works better for you. Or you can do it in a Word or Google Doc file. You all have access to Google Docs through your NNEC Gmail account. So if you're not sure how to do that and you'd like to do that, let me know and I can show you how to do that. There are 3 methods for submitting your work. So the first is to scan your work in if you write it out by hand and then send it to me. So you can scan if you have a smartphone with your iPhone app or an Android Google Drive app. Both of them have scan functions. If you don't have a smartphone and you just want to take a picture or scan it through an old-fashioned printer, that works. That's totally fine too. Then you can send it to me either through email, studentwork@nnec.on.ca, and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger to bslatewahsa. The second method is to drop your work off into Lookout. So we have an outdoor mailbox at 74 Front Street. We are the big red building next to the post office, and we have a small white mailbox that you can put your work in and next to our side entrance so I can get it there. The third method is to hand your work into your DEC. Your DEC can send your work through the Express or fax it to 807-737-1732. or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, I'm happy to do that. So you can find me on Facebook and on YouTube at bslatewahsa. You can friend me on Facebook or answer accept my friend request or subscribe to my YouTube channel. And then all of our classes I post after airing onto YouTube. So because our classes at the end of my day, usually I do that the next morning. So then you can find them all in a playlist called SVN3E, our course code. And I also share them on Facebook, so you can find them there as well. We have supplementary videos that I link to or that we watch during class. So I also have a playlist there that you can find in SVN3E, where you can see all of the videos that I've linked to or that we've watched during our lessons. So if you want to rewatch them, or if you only listen to them and you want to watch the actual video, you can go there and find just the videos and not have to watch the whole course lesson if you don't want to. Science is super visual. Most learning is, and I use as many videos and visuals, pictures, diagrams as I can to really help us understand what it is that we're talking about. So connecting through either the live Zoom link or watching the replays on YouTube are really going to set you up for the most success. And so I strongly advise that you do that. If you don't have reliable internet, then you can let me know and I can send you a copy of the recordings so that you can still access them if you'd like. If you have any questions and concerns, please contact me. Please reach out to me. This is why I'm here to support you. So my email address is bronwyn.slate@nnec.on.ca. My Facebook is bslaitewahsa. You can call the office and connect with me there. The number is 807-737-1488 or toll-free 1-800-667-3703. My office hours are Monday through Friday, 9 to 4. So I'll get back to you within those time. Before we dive into our new content, I always want to position myself in relation to our subject and the way that we learn and teach. So I am a white settler, or I have white settler ancestry, though I was born in Canada. I live in Northwestern Ontario on the traditional territories of the Anishinaabe people. So I do have I have white privilege, and that guides how I walk in the world, though I try really hard to be aware of that privilege and the impacts that I have and the realities of those around me. This is my first time teaching this course, so I have lots to learn and to unlearn. That is a challenge and something that I'm striving for, but just to be aware that that is something that I am working on, and I definitely don't get things right all of the time. I will miss things. I will make assumptions. I'm trying really hard to be aware of that, but it is deeply ingrained. So I'm just owning that as we learn together. Our textbook is also very Eurocentric. So a lot of the things that it refers to are either white communities or white scientists, things like that, where we know that lots of other communities experience things in very, very different ways, and that there are scientists all over the world and knowledge keepers in different places in our communities that have a wealth of knowledge that our textbook doesn't recognize or honor. Specifically, they may use some problematic language. I haven't read it all, but I wouldn't be surprised. And also, I do know that they ignore Indigenous and Inuit and Métis knowledges and experiences, and that is also problematic. So I work to try to pull those in and draw in that experience as best as I can as a white person. But that is a barrier with the resources that we have. If anyone has any resources for me or ways that I can improve, please just reach out and let me know. I'm happy to learn and to dive into this sort of conversation deeper. Great, so today we're wrapping up Unit 1, which is We Are the Guardians of the Earth Spheres. So a reminder that in this unit, we're thinking of Earth as a superorganism where all the living things and non-living things, living parts keep the Earth healthy. Specifically, we're looking at all of Earth's spheres. So the land, the soil, the air, and the water are connected to one another, as well as to us and to the other life forms. So it's all interconnected. We can't change one without affecting the others. So in this unit, we've been learning about those spheres, about their makeups and how those spheres exist, as well as how people affect them. Today in lesson 3, we are going to be looking at common methods of sampling and monitoring of the quality of soil, water, and air over time so that we can understand how we know that our human activities are having an impact and how that is changing. It's important to understand how we can understand that. So instead of just trusting it, being able to see how actually measuring actually works. All right, so our learning goals are that at the end of this lesson, you will be able to say, I will be able to explain how soil, water, and air are sampled and tested for contaminants. And 2, I will understand the human impacts that result in soil, water, and air pollution and the associated risks to the environment. Our success criteria, so you know you've met the learning goals because 1, I can explain how erosion and lack of nutrients due to human use impacts soil health. 2, I can explain how water is sampled and tested for pollutants, specifically in drinking water. 3, I can explain how air is tested and what contaminants to look for in a sample. All right, so first off, why are sampling and watering? Why is this important? So we have learned that human activity has negative effects on soil, water, and air quality. We know that. To understand these effects, people use different sampling methods and tests to monitor soil, water, and air over time. The information they collect helps us ensure farmland and forests are healthy and productive. It also helps us learn more about how polluted air and water affect human health and natural habitats. So this is the basis that we can make the educated decisions about what we need to be doing in our environment. All right, so first we're going to look at soil. So soil core sampling is the most common way to measure soil quality. Then farmers can use this information to decide how much fertilizer and what kind of fertilizer needs to be used. Foresters learn the pH and nutrient levels of the soil, which then affects the health of the trees and bushes and plants and things. Environmentalist scientists use core sampling to measure pollution in the soil. Soil, we know, is made up of sand, silt, and clay, but they're not equally mixed. So they exist in layers, and these layers we call horizons. Soil core sampling means we get a lot of information without disturbing a lot of soil. So we dig, we take a core. It's exactly what it sounds like. So we take a sample, we dig in a long cut down, so we get down deep, and then without having to dig a big wide swatch of earth, we just dig deep in a small area. So we're going to look at what that looks like. Soil profiles you can search this up and you can see lots of examples online, but this sort of is how we measure and what's going on in our soil. So when we do a core sample, this is what we're comparing it to. So our first layer, it's called the O horizon, and this is the first layer, the top 2 inches of the soil. It is fresh to partially decomposed organic matter, particularly branches and leaves, and it varies from brown to black. So that is the top 2 inches of our soil. Then the A horizon is the second layer, and it's about 10 inches deep, up to 10 inches deep. And this is topsoil, which we talked about previously. So it's highly decomposed, mixed up organic matter. It varies from brown to gray. And it's also known as the root zone, as it's where plants like to grow. This is where they are able to access rich nutrients and hopefully allows them to be healthy. The horizon is the third layer, and it goes up to 30 inches deep. So this is also called subsoil. It's mostly clay and bedrock. The clay is due to leaching from the above layers. So the above layers extracting moisture and nutrients. And it has some root activity, but not as much as the topsoil does. And then the fourth layer is sea horizon. It is up to 48 inches deep. And this is called parent material. It's mostly weathered bedrock. So it is cracked and ground up large chunks of rock that is part of the Earth's surface. And then the final layer is called R or D horizon, depending on where you're looking. It's bedrock, so it's unweathered rocks. So it's basically just solid rock once we get down to that layer. So here is an image that shows 2 different soil profiles. So it's looking at, looks like it's like a hill front sort of, and you can see it's not amazing. I couldn't find one that, but you can sort of see where the horizons are and how they can be different. There's also an E level, which lots of places don't have. It's really, really old soil. and rocks. So lots of places don't have that anymore. But you can see that there's different thicknesses and things are slightly different. The composition, whether or not they have it, how much of it have, it varies a little bit from profile to profile. All right, so we also not just look, but there's different ways to test our soil. So, and what we can look at when we're testing soil. So a sample, so once you go through that soil profile, like take that core sample, the sampled soil is mixed up and then sent to lab for analysis. Then farmers, foresters, and environmental scientists all use the results to make decisions about how to improve the health of the soil in the area. Erosion and lower levels of organic material are the primary reasons for poor soil quality. So people who are working to improve the soil quality might add organic matter like manure or compost. They also might plant cover crops, for example, rye, soybeans, sweet clover, that helps add nutrients and protect the soil. So when folks are monitoring soil quality, the sorts of things that they are testing for and looking at are in this chart that is also in your workbook. So first test is soil color. So that is exactly what it sounds like, the surface soil color. A lighter colored soil is a sign of erosion, whereas a darker colored soil means more organic matter, like humus, which we talked about previously. Soil life, so the presence of earthworms, so the number of them and how large and healthy they're and how healthy large the holes are that they leave, are what we're actually measuring, we're testing. So 0 to 1 worm in a shovel full of topsoil or no holes is poor soil. Having earthworms is a sign of healthy soil. So 10 or more worms in a shovel full of topsoil and 10 or more holes per square meter is a sign of good, healthy soil. Soil life, so the smell, this is just smell. That's exactly what the description, that's how we do it, is that we smell it. If it has a swampy smell, it's poor soil. If it has a sweet forest smell, then it's good, healthy soil. Having organic matter like plant roots, so this includes both living and dead things, decomposing things, leftover plant matter is what we're looking at. So no visible roots or leftover plant matter is a sign of poor soil, whereas having roots and leftover plant matter is a sign of good soil. Compacted soil, so how much it is pushed and squashed together. It's if it has, this also goes with porosity, if we remember, in terms of those soil particles being how compact they are. So if the soil is dense and the plants have badly formed roots, this is a sign of poor soil. If the soil crumbles easily and feels spongy and the roots are able to move through the soil, this is a sign of good soil. Water holding capacity, so how well the soil can hold water. If it is dry, then it's poor. If it is moist and to a certain degree, it is good soil. And then the pH level, the acidity or the alkalinity of soil. Remember, we talked about pH scale before. So if it's too acidic, so less than 5 or equal to 5.2, or too alkaline, so greater than or equal to 7.9, this is poor soil. So certain nutrient or certain mineral nutrients can become toxic or are not able to be used by plants if there's too much of it. So that's why it's poor. A soil range of pH is between 6.0 and 7.4 is the best for the majority of crops. It's how soil is tested. That's a rough overview of what we're looking for when folks are testing the soil and trying to decide how they can, what needs to be introduced or changed in order to improve the health of the soil. Great, so now you should be able to do the key questions on page 19 of your workbook. They're the check your understanding questions 1 through 3. Okay, now we're going to look at water. So water sampling is the next thing that we're going to be talking about. So it's used to find contaminant levels. So if some contaminants are too high, this is dangerous for aquatic organisms, and it's unsafe for drinking water. So the most common way to test water is to do depth integrated sampling, which is with this long pipe. So we're going to watch a video that hopefully it's going to work. It was giving me some issues, but this video so we can actually see what is going on, which is easier than me just trying to describe it. I found once I watched it, it made a lot more sense. Sorry, for some reason it works sometimes and sometimes it doesn't. So we will just go this route.
Once you're out on the lake, you just have to take a lake sample. Make sure you've dropped an anchor. If it is windy, you might need to drop an anchor at both ends of the boat. Record the sampling time on both the plastic and hammer. Recycle the land. To prepare the phosphorus sample, you will flow the second. Into the plastic.
All right, so that just gives us a visual of how water sampling is actually done. So I found that really helpful, opposed to reading things, being able to actually see it. I find really useful to just get that you're putting this big long tube into the water and then capturing it in order to then test it. All right, so then let's think about types of testing. They talked a little bit about type of testing that they were doing specifically in the video, but generally this is the types of testing that different communities are going to test for different things. So the Ontario Ministry of the Environment regulates 3 particular types of testing, and then there's some other general testing that can be done. But the 3 that the Ministry of Ontario of the Environment does, the first is microbiological testing. And so this tests for microorganisms like total coliforms bacteria and E. coli bacteria. Not all coliforms are harmful, but some are dangerous. So a healthy water sample does not contain any E. coli. And so this is really important to test so that you can know if there are dangerous levels or not. Chemical testing. So tests are done on drinking water for various chemicals, specifically nitrates and lead. There's also radiological testing, which is tests for uranium. Low levels of uranium are normal, but higher levels can be really concerning. And then other tests can be done for drinking water in terms of testing for color, taste, odor, or tubility. And water is turbid when there is suspended matter in it. So the higher the turbidity, the cloudier the water. So when I was looking through the material in our workbook, they briefly talked about Walkerton, which is a white community in southern Ontario that had an E. coli outbreak a while ago, and there were a few deaths and a lot of people got sick. And I found it really interesting that that is the only mention of community impact that the textbook covers. This is a map from a website that I quite appreciate, which shows in Canada all of the places in Canada where there is a concern about water. So I will I'll put the link in the show notes of the video so that you can go through and look at it if you want. It is updated every day. I'm not sure how they do it, but they do it. So my screenshot is not going to be exactly the same here. And if you go in to look at it, it'll be a little bit different. But we can see that these are showing all of the different water advisories that are happening in different communities in Canada. So in the territories, in Yukon, there's 1. In Northwest Territories, there are 2. And in Nunavut, there's 1. In BC, there are 236. In Alberta, there's 12. In Saskatchewan, there's 179. In Manitoba, there's 76. In Ontario, there's 63. In Quebec, there's 82. In Brunswick, there are 5. In the other Maritimes, I guess, Nova Scotia and PEI maybe are done together. I don't know if this is saying PEI doesn't have any. I'm not sure. There are 41. And then in Newfoundland and Labrador, there's 118. So this is just, I find really interesting to see the spread. Then from here further, you can click on a province or click on select from the drop-down menu and see more specifically the advisories in your province or territory. So here I clicked on Ontario, and now we can see the layout a little bit where these advisories are happening. So the yellow markers are for boil water advisories. The red markers are do not consume. And then if there were any teal, bluish green ones, are blue-green algae advisory, which currently now in April, we don't have any, but you can see. And then what I find to be even more fascinating is that you can click on these little markers and it tells you where the advisory is and how long it's been there. And if there's any other information. So the one that I clicked on was McLeod Provincial Park, and it's been on advisory since November 2020. So that is just interesting to know. If you click through all of these, what you will end up noticing is that a lot of them are First Nation communities. And so they tell you the date. Right now, there has been changed. I've been looking at this website a lot, or over many years, and there are a lot less do not consume advisories than there used to be. So that's an improvement, but still the majority of them are First Nation communities. They also tell you how many people potentially are affected, maybe. So it's really interesting. A lot of people, when I've used this with other classes, are saying, well, I mean, sure, there's ones in Northwestern Ontario because it's so remote, it's hard to get there and fix things. But even if you go down to Southwestern Ontario, you can see sometimes there are campgrounds and parks, but then there's also less now than there used to be, which is great. But there's also First Nations in Southern Ontario that don't have access to clean water that are still under boil advisories. And so that's just really telling in terms of the priorities of our government and our communities of who has access to clean water and who doesn't. So this is a really interesting place to explore. Like I remember the BC has a ton, so we can quickly go look over at BC and you can just see everywhere what's going on. We can maybe see this one that I just clicked on is a community that says that it's been since 1992. Like that is 30 years ago. And you can see that there's a blue-green algae one as well as a few red ones that are do not consume. So it's interesting to sort of explore that a little bit of how much we think that Canada has lots of really clean water, that it's a really healthy place, and that there's so many places that have boil water advisory, which I just think is interesting. So that's someplace that you can go in and check out if you are interested. Clicked on the wrong part of the screen. Okay, so I also looked up in terms of that things have been shifting. This graphic is from a Canadian government website, so I have to admit that I don't know the interworkings of First Nations water access and how the government has been supportive. The government is saying these things, and hopefully that they are true. But I believe that still needs to be done. But they together, the government of Canada, as well as First Nation communities, have been improving infrastructure on reserves in First Nation communities. They've been keeping water systems running and properly staffed, which is really important. They've been ending long-term drinking water advisories, which is essential. They've been supporting First Nations control of water delivery. They've been preventing short-term advisories from becoming long-term. So if something does happen, it doesn't get pushed back and forgotten about. And they are making progress. There are less and less water advisories in communities, which is really, really great. Since 2015, $5.2 billion have been invested. I am hopeful that our communities, many folks can see the direct impact on this. I don't know. I live in a community that does have access to fresh drinking water that's safe. So I'm privileged like that. I don't know exactly what the reality is for other folks. I'm sure many of you know firsthand the impacts of having polluted water. But according to this graphic, 131 long-term drinking water advisories have been lifted since 2015. There are 34 remaining in 29 communities. Of course, that's something that shifts and changes over time. This is a static image, so we don't know exactly when this was exactly published. I couldn't find that. But there have been 611 projects, including 108 water treatment plants, and then also 503 upgrades that have been finally funded, which is really good. And they say 212 short-term drinking water advisories have been prevented from becoming long-term, which is also very good. It's not perfect, but it is moving in the right direction, hopefully. Okay, so now you can do the key questions on page 22, the check your understanding 1 through 3. And then finally, we're going to look at air. So when we're talking about air pollution, a lot of it has to do with factories and the emissions that they put into the air. So stack sampling is one way that a lot of air is tested to make sure that the emissions that are being put into the air are not really, really dangerous. On the screen, I have two graphics of two images of factories. This one on the top is from Dryden, the paper mill, the pulp mill there. So if anyone has been to Dryden, you know the stinky Dryden smell that is coming from the mill, and you can have seen the smokestacks with these plumes of emissions. And then this other one, I believe, is from Hamilton, which is in Southern Ontario, which just shows, again, it's a clear day. So you can see the amount of exhaust or pollutants that are being put into the air. So most of the pollutants in the air come from industrial plants fueled by fossil fuels. So it's all connected to what we've talked about before. This includes pulp and paper mills, metal smelters, oil and gas processors. They pump chemical gases like sulfur, mercury, and carbon into the air through these smokestacks. These are called emissions, as I've been saying. Companies are mandated to regularly sample and monitor their emissions. So stack sampling is how they do this. So I wasn't able to find, I was looking for a video to see if we could understand how this works. But I wasn't able to find one. I found a lot of videos of people climbing up smokestacks and looking out over the horizon, but not a lot. It's loud. It's not really easy to tell exactly what they're doing. So here is a static image that shows a cross section of a smokestack. And then there's this probe that gets stuck in through a vent, and the air gets sucked into the probe. You watch a whole bunch of videos or learn a lot about in terms of how that is actually done, in terms of the speed of the airflow and particles, and well, that is more than what we need to understand. And then that air is tested it comes through these testing machines. Again, we don't need to understand exactly what's going on within these testing machines, and then inputs are put out so that we understand, and those are read and interpreted. So one particular thing that we are testing for is fine particulate matter. So the main ingredients of smog, along with ozone O3, is fine particulate matter. It's a mix of solid particles and liquid droplets. This includes aerosols, smoke, and dust. That's created through chemical reactions and burning of fuel. It's known as PM 2.5 because particles measure 2.5 micrometers or less. Now, this is a new unit of measurement that many folks may not be familiar with. So this is a Greek letter mu, which looks like a U kind of with a long front tail. So it's mu m, stands for micrometer, which is a 1/1,000,000th of a meter. So to give you a little bit of an understanding of how big that is, a strand of human hair is approximately 100 micrometers. So 2.5 micrometers is significantly smaller than the width of a hair. So these particles are very fine, are very small. And that means that this is partially why they're dangerous. So PM 2.5 can be inhaled and can cause serious health problems. So because they are so fine, because they are so small, if you're around them, we can inhale them, and this is not what our body needs. So we're going to watch another video about particular matter. Hopefully it's going to work for me.
The air we breathe is the most important component for our livelihood, just like the food we eat and food we drink. But it is often taken for granted by us. Thus, there is a use of air quality index, AQI, which is used to measure the level of air quality in the air.
So the AQI is used around the world, and it measures the fine particular matter in our air. So the first thing to note is that in your workbook, it is different than every other AQI that I was able to find when I was looking online to find a colorful example. So I like to have something that differentiates that and makes it easier to understand. And nothing has the same values that are on in your workbook. I am not sure why your workbook has those values. I couldn't find anything in terms of there being a change. I assume that it's just outdated. I'm not really sure. So just know that your workbook is different and that the ones that we are sharing here on the screen are what are currently being used for the air quality index. So we have the 6 levels like the video mentioned. So we have good, which is a measure of 0 to 50. So the air quality is considered satisfactory and air pollution possesses little or no risk. So there might still be particles in the air, but they're not having any impact on us. The next level is moderate, which is 51 to 100. The air quality is acceptable. However, some pollutants may be of moderate health concern for a very small number of people who are unusually sensitive to air pollution. So this is something to be concerned about, to know your health risks and things like that. So then the next level is unhealthy for sensitive groups. So this is 101 to 150. And members of sensitive groups may experience health effects, but generally still the public will not be affected very much. Then we get to unhealthy. So at 151 to 200, this is when everyone's likely to be experiencing health effects to some degree. The people who are already experiencing health effects are going to experience much more serious health effects at this point. Then we go to very unhealthy, which is 201 to 300. So this is when we start having health alerts, and now everyone's most likely going to be experiencing serious health effects. And then lastly, we have hazardous, which is greater than 300. This, I believe, goes up to 500, the scale. So this is like severe health warnings and emergency conditions, and the entire population is going to be affected quite significantly. So these numbers you can actually find different places to see what your air quality is. I found a map, a website online that shows you that you can go in and you can look at what the air quality is in your region. So the website is IQ Air. I will include this in the show notes of our YouTube video. So here we can click on here and see, hopefully it's going to work for me. So we can see the air quality of Canada. And so we can see this map. Part of what I love about this map, just because I'm a geek, is that you can see airflow. They show you air currents, all of these little, looks like almost like little comments. They are the movement of air. So you can see that to see how air is traveling and how that actually, here you can sort of see how that potentially takes some smog or pollution or things like that, and how that travels. Then they have the same good to hazardous rating that we just went through. And you can then see where they are monitoring. We have the general air quality is one layer that they put on. So in Canada, most of the air quality right now is green. So healthy, good. And then the dots are where they're actually monitoring. So in Canada, there are a lot along where there's more populated, where there's not as much population, there are not air monitors. And then you can see in the US, there have a ton everywhere. Then you also can see where fires are currently. So this might be something that would be interesting to come back to at another time during the year. Right now in April, there are not very many fires in North America. Hopefully that continues, but it'd be interesting to see that as it changes. And then of course the wind, which you can turn off, but you can have the wind, which shows you the air currents. Then it gives us real-time rankings. So it can show you the most polluted places in Canada. Ottawa is the third most polluted place in Canada, which is interesting, with a rating of 67. That still falls in the moderate, which most folks will not find to be unhealthy, will not affect their air quality. Then if you continue to scroll down, it tells you the PM 2.5 concentration, and it tells you the cleanest city from 2021, so from last year, and the most polluted city from 2021. And then it also tells you continue, you can find out the best, the cleanest cities currently, the real-time rankings. But again, this is going to be like, these are all 0, great, but they're 0 today. That doesn't mean that they're 0 every single day. And you can see our ranking within the countries that they have ranked on here. And we currently are 95 out of 118. So we are on the lower end of the concerning area. So there are some places that have red and orange. So they're not very unhealthy or hazardous, but they are unhealthy and for sensitive groups and for the general public for a few of these countries. So you can also go and, so that's Canada, but you can look specifically, you can look at other countries, or you can look at the world as a whole. So this is another view of looking at the same information, but as the world as a whole. So I found that very interesting. And so you can see places where there is very unhealthy, there's air monitoring places that are really unhealthy. You can see where there's fires in the world. It's interesting to see, and you sort of analyze, consider the equitable or equity within our world, and the places that extract resources from other places, and the places where the resources are extracted. And that's just, I find really interesting to see those interconnectedness in terms of the places that we really privileged people send like factories into other places in the world to create, that you get cheap labor, things like that. And those, the air quality in those places are really concerning, or places where there's really high population, it's more concerning, or things like that, or places where are really, really wealthy countries, because we are, based in terms of colonization and historically robbing other places in the world of their resources, are places that have really good air quality. So that's just an interesting thing to see how those things are connected within our world. So I found that to be a pretty cool map to check out to see what's going on in our world. So I will link it, you can check it out if you'd like. So some poor air quality symptoms to just be aware of. Air quality doesn't affect everyone in the same way. Different people are going to react in different ways, just like everything, but often these are the most common things that people report. So dryness and irritation of the eyes, nose, throat, and skin, headaches, fatigue, shortness of breath, hypersensitivity and allergies, sinus congestion, coughing and sneezing, dizziness, nausea. Unfortunately, these can be symptoms of other things, so they're not necessarily due to poor air quality. It could just be a cold or flu. It could be COVID-19, as we have to include that in all of our analysis of how we're feeling, which makes it really hard to identify and resolve air quality issues because the symptoms of it could be attributed to many other things. So it's just something to be aware of if you're finding you're struggling with things in your community or in your workplace. It could be something that air quality you might be able to improve. So then in general, what can we do to reduce air pollution, just to sort of overall think about it? So we can conserve energy at home, at work, everywhere, just in terms of not burning more fossil fuels is going to be beneficial. We can look for the Energy Star label when buying home and office equipment. So again, this is going to be more energy efficient and not be as pollutant. We can carpool, use public transportation, bike, or walk whenever possible. Follow gasoline refueling instructions for efficient vapor recovery. Being careful not to spill fuel, and always tightening your gas cap securely. We consider purchasing portable gasoline containers labeled spill proof when available. So just being conscious of if we are using fossil fuels, how we're using them. We can keep our car, boat, and other engines properly tuned so that they use fuel most efficiently and therefore not contributing more pollutants to the air. We can make sure our tires are properly inflated, as that has an impact on fuel consumption. We can use environmentally safe paints and cleaning products whenever possible. We can mulch and compost our leaves and our yard waste instead of burning them. We can consider using gas logs instead of wood. We can also pressure our governments and businesses to take action. So this list of things that we can do are all things that we can potentially do at home in our own lives, which is great to have that individual action that we can take. But it's also really important to remember that this is just not an individual problem. This is not just a, well, if every individual person were to just be better, then it would all be better. It is actually a reflection of the choices that the government are making and the businesses and corporations. And so we can pressure them by how we vote, by what products we buy, where we spend our money, what we support, in terms of being more environmentally friendly and having an impact on our air pollution. All right, so let's do our lesson 3 highlights. What did we cover today? So we talked about soil. In soil, we talked about core soil testing and soil profiles in terms of how to figure out the health of soil. For water, we talked about how water sampling and testing is completed and using the deep, can't remember what it's called in this moment, but the long tube that tests or that collects water. And then we talked about boil advisories and where they are and how that is an inequitable reality. And then we talked about air pollution, particularly we talked about stack sampling and how that works for testing air quality. And then the air quality index, which we all can have access to. You can either go to that website that I showed you, and also it sometimes shows up on if you have like a weather app or you go to the weather network. If there is concerning air quality, it'll show up there in your community. So success criteria number 1, I can explain how erosion and lack of nutrients due to human use impacts soil health. 2, I can explain how water is sampled and tested for pollutants, drinking water. And 3, I can explain how air is tested and what contaminants to look for in a sample. So hopefully now we can do that a little bit. We have a bit of an understanding of not only what pollution is, but how we measure it and how we can analyze it in order to make improvements. You're now able to do the key questions on page 27. They are the review questions 1 through 11. And if you have any questions, please reach out and contact me. You can always get a hold of me through various means. You can call the office 807-737-1488 or toll free 1-800-667-3703. You can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at Slate Wahsa. You can watch this replay and rewatch any of the videos, or check out the websites that we checked out today through my YouTube at Slate Wahsa. My hours are 9 to 4 on Monday through Friday. So I'm always happy to chat and explore these concepts further. Just reach out and let me know that you'd like to connect. Thanks so much for joining me. I hope you have a lovely long weekend and are able to enjoy some sunshine and not just a lot of snow. Which